Hey everyone, welcome back. We're always trying to find more sustainable, greener energy solutions, right?
Absolutely.
And
It's a hot topic.
it is a hot topic. But it's even hotter? All that heat energy that's just going to waste every single day.
Oh, I see where you're going with this.
Yeah, we're talking about like industrial processes, geothermal sources, heck, even the heat coming off a power plant.
It's true. A lot of energy just get vented away. It's a shame, really.
It is. But that's what we're diving into today.
Okay, I'm all ears. What are we looking at?
This really neat bit of engineering, a new condenser design, and it could make something called an organic Rankine cycle system, or ORC, way more efficient.
ORCs. Very interesting. I'm excited to hear more about this.
Yes, stick with us, because by the end of this, you'll know how this tech works, A&D, why it matters for a sustainable future, right?
Yeah.
And, well, I've got our expert here to, help us understand it all.
Happy to help clear things up.
So before we get into the nitty-gritty of this new design, can you give us a quick explanation of what an organic Rankine cycle is and how it's different from like a traditional Rankine cycle?
Okay, so picture this. A classic steam engine. Water heats up, turns to steam. That steam spins a turbine, generates power, then cools back down to water, and you repeat the whole thing.
Hmm.
That's a Rankine cycle in a nutshell.
Okay, makes sense.
Now, in ORC, it works basically the same way, but instead of water, it uses a special fluid with a much lower boiling point.
Interesting. So what does that change?
It's a game changer because it means these ORCs can extract energy from sources that wouldn't be hot enough for a traditional steam system,
Yeah.
like industrial waste heat or geothermal, stuff that's, well, usually just vented away, considered useless.
So it's like we're getting a second chance to snag that energy that would have been wasted.
You got it. And that's where the condenser comes in, and that's what our source material focuses on today. The condenser is crucial because it's where that hot vapor cools down, turns back into liquid, ready to be reheated, and the cycle starts again.
Makes sense.
But here's the kicker. The more efficient that condensation process, the more power you can squeeze out of the whole system.
Got it. So it's all about efficiency, like every step of the way.
Right.
Now, our source material today, it really dives deep, and I mean deep, into a very specific condenser design for an ORC using R600A refrigerant. And man, there are equations and calculations galore.
Sounds intense?
It was a lot, to be honest. I felt a little lost in those numbers.
Mhm.
What are the key things we should be paying attention to?
Yeah, the researchers definitely did a deep, deep dive into the technical stuff. Basically, they were trying to figure out what factors affect how well the condenser performs, and they found three main things.
Okay, what are those three things?
First up, you've got the logarithmic temperature difference. Think of it this way. If you've got a pot of soup and you want to cool it down quickly, what do?
Put in some cold water.
Exactly.
Yeah.
The bigger the temperature difference between that hot soup and the cold water, the faster it cools, right? Well, it's the same idea here with the condenser.
So a greater temperature difference between the vapor and whatever's cooling it means more efficient heat transfer and a more efficient condenser overall.
You got it. And a more efficient condenser equals a more powerful and efficient ORC. The second thing they looked at was the heat transfer coefficient. This one's a little tougher to visualize, but basically it's about how easily heat can move from the vapor to that cooling medium.
I see.
Think of it like, say, the material of a cooking pot. Some materials, like copper, are amazing heat conductors, right? So they transfer heat really quickly and easily. Others, not so much. In our condenser's case, a higher heat transfer coefficient means faster condensation and, you guessed it, better overall system performance.
Okay, got it. So we've got bigger temperature difference, higher heat transfer coefficient. It's all making sense now. What's the third thing?
All right, so the third one is pressure drop. Ideally, you want to keep the pressure drop in the condenser as low as possible. Picture a garden hose. You know how if there's a kink in the hose, it makes it harder for the water to flow?
Right.
It's the same idea in the condenser. Any resistance to that vapor flow reduces how efficient the system is.
Got it. Keep things flowing smoothly. Okay, so knowing all that, how do these engineers actually design the condenser? What makes their approach special?
Well, they went with a classic, the shell and tube design. It's really robust and simple.
Okay, I've heard of that one.
Basically, picture a big cylinder, that's your shell, with a bunch of tubes going through it. The hot vapor flows around these tubes while the cooling medium's flowing inside them, so you get a really large surface area for that heat exchange.
So elegant, so simple. But I'm guessing the innovations in the specifics, did they say how they tweaked this design, to nail those key parameters we were talking about?
Absolutely. They really focused on the arrangement of the tubes inside the shell.
Yeah.
They found that just by being really, really precise about the spacing and angling of the tubes, they could really make a
Make
difference.
a difference how?
They got a much better heat transfer coefficient, and they were able to minimize that pressure drop we talked about.
So it's not just the basic idea, it's about getting those little details just right. Really cool to see that kind of engineering. But okay, we've talked a lot about the how. Now let's talk about the why.
The why. You mean why put so much effort into making a condenser more efficient?
Exactly. What's the big picture impact?
Well, think about it. A more efficient condenser means a more efficient ORC, right? And that means we get more electricity from that same amount of waste heat.
Right, right.
We're talking about making industrial processes less wasteful, lowering those energy costs, relying less on fossil fuels. It's a win-win.
It's like we're getting more bang for our buck.
Mm-hmm.
But the buck is waste heat and the bang is clean energy. I love it. And this obviously has big implications for sustainability, am I right?
Absolutely. I mean, think about it. If we can grab all that waste heat that's just being dumped into the atmosphere, we can make a real difference in those carbon emissions. And ORCs can use these lower temperature sources, so suddenly we can get renewable energy from a lot more places.
Okay, now you're speaking my language. Give me some examples. What are some exciting ways to use this tech? What have you come across?
One area where ORCs are already doing amazing things is geothermal power generation. You know how those plants usually need crazy hot water sources, like the ones you find in those volcanic areas?
Yeah.
Well, with ORCs, you can use much lower temperatures, so suddenly you can tap into geothermal energy in way more places than we ever thought possible.
Oh, that's huge. We always hear about geothermal, but this could actually make it practical in a lot more places. What else?
Another application that's really cool is using this for waste heat recovery. So in industries like manufacturing or power generation, tons of energy are lost as heat, right?
Yeah, makes sense.
But what if you could capture that heat and use it to make electricity, like right there on site?
It's like closing the loop,
Yeah.
creating the self-sufficient, sustainable system. I'm starting to really see the potential here.
Right. And it's not just about these huge industrial uses. People are looking at how to use ORCs for smaller projects too. Like imagine capturing waste heat from a restaurant kitchen or even residential water heaters.
I was reading about a project, I think it was a bakery. They used a small ORC system to get electricity from the heat of their ovens,
There you go. See?
and they were able to power a big chunk of the bakery with it. It's really cool stuff.
And that's just one example, really. The possibilities are huge. And as this technology keeps getting better and cheaper, we're going to see even more creative, innovative uses popping up.
I love talking about this cutting-edge tech. It feels like we're on the verge of a major shift in how we think about energy. But it all comes down to those core principles, that efficiency. And that's where our condenser design comes in, right?
Exactly. They're all connected. If we can make something as small as a condenser way more efficient, then boom, the whole ORC system gets better. And that can literally transform entire industries. It paves the way for a more sustainable future. I'm excited about it.
Speaking of sustainability, I noticed our source material talked about what they made this new condenser out of. Stainless steel. It's super durable, of course.
Yeah.
But it's not the cheapest option. Did they talk about the cost of using it?
Oh, yeah, they did. And it's that trade-off, right? Spend a bit more upfront for something that'll last way longer.
Yeah, makes sense.
Stainless steel might be pricier initially, but it's stainless. It's not going to rust out on you. So less maintenance, fewer replacements.
So you save money in the long run
Yeah.
because you're not fixing it all the time.
Yeah.
It's like they say, got to spend money to save money.
Exactly. Plus, remember how we were talking about how important it is for the material to play nice with the refrigerant?
Right, right. You don't want any weird reactions happening in there.
Exactly. And lucky for us, stainless steel gets along perfectly with that R600A refrigerant. So that means the whole system's going to last longer and be more efficient.
It's all those little choices, right? They add up to a way better and ultimately more sustainable design. This has been a really cool deep dive. We went from like the basics of ORCs all the way to like the really detailed engineering of this new condenser design.
And we're just scratching the surface. There's so much happening in the sustainable energy world, so much to learn about.
That's why we do this show.
Yeah.
Before we go, I got to ask, we talked about all these big industrial uses, but what about smaller scale? Could we see this ORC tech in our homes one day? What do you think?
People are definitely working on it. There are challenges, of course, like making it affordable for homes and businesses, figuring out how to make the tech smaller, but it's totally possible.
Imagine if restaurants could just power themselves with the heat from their ovens,
Yeah.
or homes using the heat from showers.
Right. It's about changing how we think, not just using energy, but capturing it, reusing it. It could be amazing.
It's a really exciting future. All right, everyone, I hope this has got you thinking about ORCs and just how cool the engineering behind them is. But we want to hear from you. If you could pick one use for ORC tech, any use at all, what would it be? No limits. Let us know on social media. And until next time, keep those brains buzzing.